Of course, those of you that were away, I might pick on you to help you learn. Okay. So Noah, my friend, 1A, what are they asking me to find? Okay. By the way, remember how tough that was at the beginning of the year? One of the nice things in physics with the word problems, it's usually pretty easy to figure out what they're asking you to find, at least. How much what? Okay, so don't write this down. You would say at first, well, I know that work equals force times distance, but then if you read the question, do you see a force? Is there any newtons anywhere, Noah? No. Do you see a distance? Is there meters? I see meters per second. Is there meters anywhere? No. You know what? That's not going to work. No pun intended. Oh, work is also, don't write this down, the area under a force versus distance graph. Did they give you a graph? No. So there is a third definition of work, and this is on your formula sheet. It's the change in potential, change in kinetic. Change in potential usually occurs because there's a change in height. That's gravitational potential. Oscar, do you sense a change in height mentioned in this question at all? You know what? I think we're supposed to assume we're on flat level ground, which really means that. And then I say to you, hey, what's change in kinetic? What's change in anything? This is worth memorizing. Final. Minus initial. Why can I do this? What's zero? Why? What word tells me that? Okay. So we're going to get a negative answer, and yeah, I'm going to be fussy. You should get a negative answer. What we're really saying is you're losing, the car has to lose energy, or the vehicle has to lose energy. I'm going to get negative a half m v initial squared. Negative 0.5, 950, 45 squared. Negative 0.5 times 950 times 45 squared. And I get negative, I've just noticed my calculator lately has been doing this little squiggly thing, and I didn't pick up into that, but now I'm seeing it all the time. Is that right? So I'll go negative 9.6 times 10 to the 1, 2, 3, 4, 5? One mark, half mark off if you missed a negative. All right. Nick, what does B want me to find?
The minimum force and friction.
Did you say force?
Yeah.
Okay. What did we find in part A?
Work.
Be nice if there was an equation, maybe a concept that had force and work in it. Oh! What's our other definition of work? Work equals what times what, my friend? So force equals work over distance. Would that be correct? Yeah. And hopefully I've convinced you this is far superior than the triangle, but like you're getting good at being able to rewrite equations in your head. I'm good with it. It's a great shortcut, and you don't have to show your work, except you have to show the work because we're finding work. Anyway, okay, but you don't have to show, you know what I mean. I'm going to use the full answer, which was 961,875. Now here, I'm not going to be as fussy with the negative, because here, work is a scalar, so the negative means you lost energy. Here, force is a vector. You know what the negative means? In the opposite direction that you're traveling. If you're going forwards, I'm telling you to come to a stop. Friction better be acting backwards. Otherwise, you ain't stopping. Okay? Make that decimal a bit bigger. So negative, what is it? Negative 6,400 newtons. But if you don't have the negative, I'm not going to freak out. In fact, I'm kind of going to go like that. Is that okay? Is there a part C? Let me guess. What's me with you? Is that what I would have asked? Yes. Spence, what does part C want me to find? Coefficient difference. Where does mu, what's the equation that appears in? equals what? I agree with you. We have mu times the normal. I don't want the other side, though. Hey, what did I find in part B? What did I find in part B? Don't overcomplicate it. Of? And that is in this okay, and now I know I'm on the right track. That's why I had to go in this order. I couldn't say part C right away, find mu. I had to say, you gotta find the other stuff first. You with me so far? Yeah. Okay? And I think we can reasonably assume in our free body diagram, look. I don't know the normal force, but look. I think the free body diagram would look like this. And you'd say, Mr. Dueck, it's going forward. Yeah, it's going forwards, but the force is backwards because it's slowing down. So there is no forwards force in my free body diagram. I think we can then say mu is going to be friction divided by the normal force. Friction is 6412.5 divided by, I don't know the normal force. Oh, but look. I know the force is the same size as the normal force. So it's going to be 6412.5 divided by, please tell me, did I give you the mass? 950 times 9.8 divided by bracket 950 times 9.8. I'm going to ignore the negative, but is mu 0.69? Yep. Units? None. Good. Okay. I think I told you before we started marking, but I'll say it. I like this question. You know what? I like every one of these questions. Number 2 is the one I'm not sure about. This used to not be on the test, but I liked it so much I think I've added it to the test now. This is RC&P math investigation. So it says this: an RC&P officer is investigating an accident. A car has struck a pedestrian. There are no witnesses. The officer measures the coefficient of friction to be 0.55, and he measures skid marks that are 52 meters long. What's the minimum initial speed? By the way, Kyle, what's this question asking me to find? VI. This is the same as number 1, but totally backwards. Notice in number 2, I'm giving you mu. I'm giving you the distance. So with mu, you should be able to figure out what friction was. You should be able to figure out what VI was. We're going to do the same question, Thomas, but backwards. We're going to say, okay, work equals the change in potential plus the change in kinetic. Oscar is saying, I think we can do that. There's no hill. I agree with Oscar. Which is going to be KE final minus KE initial. Carson says we can do that. I'm going to ditch the negative for the rest of the question because all I want is the magnitude. I know there's a negative right here. I'm just going to say, okay, work equals a half mv initial squared. But Nick, you said work was what times what? Force times distance equals a half mv initial squared. Now, if you jump straight to that line, that's fine, but this is where it comes from. Which force? What force is doing the stopping? Spencer. Which force? Yeah. Which force did the stopping in the previous question, my friend? Uh-huh. Okay. We're trying to find this. We'll get this by itself eventually. Oh, Spencer. Friction is what times what? So if I hear you, I think I can say mu Fn times d equals a half mv initial squared. Is that what you're saying, me? Yes. I don't know the normal force. Oh, but look. It's the same free body diagram. I know another force the same size as the normal force. Which one? Okay, so I can say this. Mu mg times d equals a half mv initial squared. Did I tell you the mass of the car in the question? Did I need to tell you the mass of the car in the question? It's kind of handy because there's an m in everything. Kyle, what did you say we were? I think it was you. What did you say we were trying to find? Oh, VI. So, you know what? To move the 1/2 over, I'm going to times by 2. And then how do I get rid of a squared? Oh, here it is. The initial speed is going to be the square root of 2 mu g d. The square root of 2. What's mu? I don't know what's mu with you. 0.5, 0.55. G, 9.8. D, 52. 2 times 0.55 times 9.8 times 52 square root. And I get, is that right? 23.7? I'm curious if he would be charged times by 3.6. 85 kilometers. Well, it would, you know what? It would depend. Is it in a school zone? Is that what I said? Oh, crosswalk, then probably. Probably, okay. Why did I say minimum initial speed? He could have slowed down before skidding, right? And you could argue that safely in a court of law. You could say he's going at least 85 kilometers per hour. Probably you would be able to make a case. I don't see 85 is low heat speed. If you're over 100, I think probably you'd be able to justify like a vehicular homicide charge or something like that. Here, probably manslaughter or reckless endangerment or something like that. That's assuming the pedestrian was terminal. Hopefully they weren't. For 3 marks, first of all, if you got the right answer, Natasha, 3 out of 3. 1, 2, 3, 4, 5. I was hoping there was like 6 lines of work. Well, you know what? I would almost certainly give you 1 mark if I saw work equals change in potential. Plus, I would give you 1 mark if I saw force of friction times distance equals a half mv initial squared. I would give, you know what? I'm even going to say no marks for that. I would give you 1 mark if I saw VI equals the square root of 2 mu GD, and I would give you 1 mark for the answer. Really, this should probably be a 4-mark question, because that's a lot of, no pun intended, work. Number 3, water slides. Colin, is there a change in height in this question?
Yeah.
Is there a change in speed in this question?
Yeah.
Is there a yucky, curvy path? I'm betting this is going to be a conservation of energy question. I haven't even read it yet, but that's kind of where I'd be leaning towards. Let's see. They gave me the speed slide, how fast at the bottom if we ignore friction. Yep. What do they want me to find, Colin?
Yeah.
This is a job for conservation of energy. Oh, ignore friction, so no plus heat. Are any of these 0? Are we starting at rest? No. Are we starting on the ground? Are we ending up at rest? No, because they want me to find final speed. Are we ending up on the ground? Technically, no, but again, Riley, this is the lovely thing. Because conservation of energy is a scalar, even though the ground is right there, I'm going to let the ground be right there. It'll make the math way nicer. I can put it wherever I want, and it'll all take care of itself. So I can do that. This is going to be a half mv initial squared plus mg h initial equals a half mv final squared. Oh. And then this is where I'm going to use, Justin, a clever trick. What do I want to find, Colin? I want to get that by itself. what you can do is you can times that by 2, times that by 2, and times that by 2. But you have to do all three, even though there's no fraction in front of the MGH. Equation solving rules say, Kyle, you got to do the same thing to everything. Why is that nice? It gets rid of that, it gets rid of that. And you end up with VI squared plus 2GH equals VF squared, which is actually our VF squared equals VI squared plus 2AD, because G is an acceleration and H is a distance. That's where that equation comes from. How to get rid of a squared? So I'm going to get was it 8.3? I think it was. 8.3 squared and 21 meters plus 20, well, that's not 21, Mr. Dueck. 9.8, 21. 8.3 squared plus 2 times 9.8 times 21. Square root of that. You get 21.9? 22, if you said 22, I'd give you. Yeah. You sure you're going to make it up to your long weekend? Okay. How many marks is that worth? You know what? I'd probably go 1 mark, 1 mark, 1 mark, 1 mark. Yeah? Suppose they're only going 16 meters per second at the bottom. How much energy was transformed? By the way, I said transformed into heat. Actually, a lot of it gets passed on to the water molecules because you give the water molecules some kinetic energy because you're pushing them. But I didn't want to get into all that, so I just said, yeah, we'll call it all heat. Well, KE initial plus PE initial equals KE final plus PE final plus heat. And I want to, oh, that's still 0. I want to get the heat by itself, so I'm going to move this over. How will I move that over? I think I'll subtract it. I always have a lot of people, for some reason, that divide it, and I don't know why. No, subtract it over, because it's plussing onto the heat. It's going to be KE initial plus PE initial minus KE final. That equals the heat. The heat is going to be a half mv initial squared plus mgh initial minus a half mv final squared. Okay, does the mass cancel this time? It does. I disagree. Ready, Cade? Is there an M there? Say yes. Is there an M there? Is there an M there? Is there an M there? So does the mass cancel? Nope. Nope. What that means is someone bigger moves more water. Oh, yeah, okay. That makes sense to me. It's why little kids on those water slides go shooting out like crazy, and us that are larger, we don't build up the same speed anymore, right? I'm assuming you've all been on a water slide. If you haven't, look behind you. There's a life somewhere. Go get one. 0.5. What was the mass of the kid? 45? Did I just say get a life? Yeah, okay, fine. 8.3 squared plus 45, 9.8. What was the initial height? 21? Anyone? 21? Yes? And then minus a half, 45, 16. Okay, now it's plug and chug. 0.5 times 45 times 8.3 squared plus 45 times 9.8 times 21. There's how much energy you start with, minus 0.5 times 45 times 16 squared. You'll lose that. You still have that much at the bottom. What vanished? 5,051. I'll go 5,050. Is that right? People nodding? 4 marks. I would probably go something like 1 mark for that, 1 mark for that, 1 mark for this line, and 1 mark for the answer. But if you got the right answer, again, 4 out of 4. please tell me I have a roller coaster question on here. Do I? Oh, a little worried there. A roller coaster starts from a standstill at rest. That's going to be convenient. At the top of a 90-meter hill. With passengers, the mass of the roller coaster is 400 kilograms. What's its velocity at the bottom of the hill? Okay. So this isn't quite accurate because on a roller coaster, at the top of the hills, you still have some velocity. But all that would mean is one thing wouldn't cancel. Okay, fine. Is there a change in height, Angela? Is there a change in speed? Is there a yucky, curvy path? I think this is a job for conservation of energy. KE initial, PE initial, KE final, PE final. I think I can say we started at rest, and at the bottom of the hill, we're at the bottom of the hill. Oh, this is actually going to be kind of nice. I'm going to get MGH initial, a half MV final squared. Kate, is there an M in everything this time? Do the masses cancel this time? Excellent. We want V final. You know what? I'm also going to go times by 2. And then how to get rid of a squared, Ange? I think we've seen this before. V final is going to be the square root of 2 times G times H initial, which is going to be the square root of 2. By the way, 90 meters, that's a pretty good high roller coaster. That'll get your, pardon me? Oh, I did it again. I did, but yeah, thank you. I'm already wanting to get to the height. 9.8. 90 meters, though, is a good high roller coaster. For a while, the biggest single hill drop was Goliath at Six Flags at Magic Mountain. I've been on that one, but I think they built a bigger one now. But that Goliath, it's like probably from the top of the hill to the bottom, it's about 1, 2, 3, 4, probably 4.5 seconds of you going. It's about a 70 degree. It's very good. Oh, this works out evenly. I stole this from the internet. Somebody did some nice math for me. 42 meters per second. For 2 marks, I would probably go half mark if I saw that, half mark if I saw that, half mark for that, and a half mark for the answer. Is there a part B? How fast will it be going at the top of the next hill? 3 marks. You know what? I'm going to let this right here be initial and this be final. I could let right there be initial. The only worry then is I'm using the velocity that I just calculated in part A, which might be wrong. Okay? It might be easier and less math to do it that way, but I'll be a good test writer and I'll use the data that they gave me. So it's going to be kinetic initial plus potential initial, kinetic final plus potential final. Starting out at rest, and I think that's it. I'm not on the ground and I'm not at rest. So it's going to be mgh initial equals a half mv final squared plus mgh final. Okay, do the masses cancel here? Why, yes they do. Are you going to ask me every time I should do it? Maybe. How fast? Okay, we want to get this by itself. I'm going to minus this to this side. I haven't done one like this before with you guys. It's going to be GH initial minus GH final. That equals a half VF squared. How would I get the VF by itself? You got 2 options. You could either go times by 2 cross out, or you could divide the whole thing by a half, by 0.5. I'll do that one since that's what somebody said. Except now I've got VF squared. Help me out. Yeah? You guys have come a long way on this. I'm proud of you all. It's By the way, not only is this a nice way to do the physics, I was at the physics teachers annual general meeting about 2 weeks ago at SFU, and one of the things all the profs said they wanted kids to be better at in university was being able to rewrite formulas. They're like, why are teachers telling kids to put numbers in right away? Do it last. So I was like, yes, I make you guys do it that way. Anyways, so if you're taking physics in post-secondary, this will help. Is that right? So it's plug and chug time. 2, 9.8, initial height, 90, minus 2, 9.8, 50. By the way, here's what else we could have done, and I don't know if anybody did this. If you did, I'm impressed. Because energy is a scalar, what you could have just decided was to make this height right here 0. What would your initial height then be? Not 90, what would it be? 40, and then your final potential would have canceled. Anybody do that? I would have been really impressed, because that would be clever and lazy at the same time. Anyways, let's crunch it. 2 times 9.8 times 90 minus 2 times 9.8 times 50. 50. 28. And I said you could have also let that be a height of 40. You would just go 2 times 9.8 times 40. And lo and behold, there's your 784 again, square root 28. I stole these from the internet, and they worked out evenly. I don't care about you guys enough to make them work out evenly on a test, just so that you understand if you get decimals on the test, you're probably right. I would get more worried on a test if it did work out evenly, because that would mean as I was making up numbers, I fluked it, right? How many marks was that one? 3 marks? 1, 2, 3, 4, 5, 6, sure. Half mark, half mark, half mark, half mark, half mark, half mark, but of course if you got the right answer, 3 out of 3. I like question 5, I like question 5, I like question 5. Partly because I used to teach archery at a summer camp. And it's become an in thing again, and with all the movies that have had archers in them. But bows and arrows are actually great energy transfer devices. Only this time the potential energy is not gravitational. It's elastic, but you store it. It's stored energy because of elastic pull. Then it turns into kinetic. So you ready? A full draw is the maximum distance that an archer can pull back an arrow. Using the recurve bow shown below, a particular archer requires an average force of 130 newtons to pull a full draw of 70 centimeters. How much work? Nick, work is what times what? Let's try that first. Did they give me in this question a force in newtons? Did they give me in this question a distance in meters? Sort of. I'll have to do a conversion. They gave it to me in what? Okay, 0.7. Oh, look at that. Apparently, I can tell you how many joules of energy were stored in this bow by going force times distance. It was, 130 newtons of force? Pulled back 0.7. And this is how you can actually calculate how much energy you've stored in something. $91 joules of energy. What kind of energy? Potential. Not gravitational potential, just potential, stored energy. How much potential energy is stored in the bow? 91 joules. Not mg. No. We've just done work. We stored energy in the bow. Same answer. Same answer. What's all that stored energy going to turn into? All of that stored energy is going to turn into kinetic. All of that stored energy is going to turn into a half mv squared. All of that stored energy, they want me to get the speed. You know what? The speed is going to be 2 times 91 divided by the mass. Is that right? Square root? Times by 2 divided by m squared. Yeah. The arrow is going to leave this bow at 2 times 91 divided by 0.018. Not 0.186, that's 186 grams. 18.6 grams is 0.0186. Almost 100 meters per second, not quite, 98.9 meters per second. Is that about right? That's a little fast, but I've seen people shoot a bow. Would it cover a football field in a second? Close. Yeah, close. Only problem is most of the time when you watch it on movies, they do it in slow motion, so it's very tough for you to get a feeling for how fast it's traveling, because it's the dramatic shot, right? So you see it traveling in slow motion. I don't know how fast it travels in real life, but I shot bows enough when I used to teach it. 98.9 meters per second. For 2 marks, I would probably go half mark for that, half mark for that, half mark for that, and a half mark for the answer. What if the arrow only leaves the bow with a speed of 54 meters per second? How much energy was lost to heat? Oh, and sound, because a bow thrums when you let it go. That's some energy as well. But the handle actually does absorb some heat and get warmer. Absolutely. Well, here I would say this, that 91 joules equals the final kinetic energy plus some of it went to heat. 91 minus the kinetic energy equals the heat. The heat is going to be 91 take away a half mv squared. The heat is going to be 91 take away a half 0.0186 54 squared. The heat is going to be 91 take away a half times 0.0186 times 54 squared. 63.9, oh heck, 64 joules went into heat, and 91 take away 64, 27 joules went into making the arrow go fast. Is that okay? You can give yourself a pretend score if you want to out of 23, but I'm not going to collect or count this. I want you to hang on to this to study from.